We're now going to look at using tree diagrams in reverse to do some diagnostic work, as I will explain. Suppose we have two machines, A and B, which are producing items. One of the machines is newer, and so it produces fewer defective items. Let's call our machines A and B. And so in our tree diagram, we'll have our two machines A and B. A produces 60% of the items, so the probability that a particular item comes from machine A is 0.6, and this is 0.4. And then let's suppose, for example, that A produces 95% good items. Let's put it like this. You can either have a defective item or a not defective item from A, and the chance of a defective item is 5%, and the chance that the items it produces are okay is 95%. On the other hand, machine B is different. Let's give some numbers to this. Let's say that machine B only produces 92% good items. It produces 8% defective items. It's the older one, if you like. And so, as before, we can work out the numbers by multiplying along. We get 0.57 by multiplying the probabilities there. We get 0.03. Here we get 0.4 times 0.92, which is 0.368. And here we get 0.4 times 0.08, which is 0.032. And just for convenience, let's make them all into the same number of decimal places. We'll call this 570 and 030, and then we've got three significant figures, 3 decimal places to each of them. Now let's turn it round. Suppose we pick an item at random from the end and we find that it's a defective item. What's the probability that it was produced by machine A? What we have here, these probabilities, are called conditional probabilities. They are the probabilities of getting defective or not defective, conditional on whether they came from machine A or machine B, and they vary, and so it matters which machine they came from. We want to try and find it the other way round. What's the probability that the item came from machine A given that it is defective? Can we work this thing backwards? And the way we do this is as follows. Let's think what these probabilities mean. If there were 1,000 items produced altogether, this top one tells us that 570 of them came from A and were not defective. 30, multiplying by 1,000, 30 were from A and defective, and so on. 368 were from B and OK. So out of 1,000 items, so from 1,000 items, the total number of defectives is, there's 30 here and there's 32 here. So altogether there are 62 defectives on average. When we create 1,000 items in this machine, 62 will be defective. Out of those defectives, how many came from A? 30. So the probability that the defective was from A is those 30 out of the 62, which is just below a half, and I've got the answer here, it's 0.484. And so this is a diagnostic testing. We're looking back from the result, we know that there are different possible causes of the result, and we can use this method, Bayes' theorem as it's called, working backwards along the tree diagram, to assess the probability of a particular cause of a final event.